of stars. Stars first phase in a nebula. A nebula is a cloud of dust and gas. The main thing in this is hydrogen. So, over millions of years, what happens is gravity compresses all that gas and dust and everything into a tight sphere, and the temperature rises up. And then, once it reaches the specific temperature, the whole thing bursts into flames. And then, that's called a protostar. So then, around the protostar is some remaining hydrogen, gas, rock, dust that was in the nebula. That it's surrounding it like a disk. And the protostar is sucking all the material from it. Over millions of years, the star gets bigger, 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 bigger. Once it reached about the size of our sun, supposing this was a middle-aged star, it will be stable. But gravity is pushing it back so that it might collapse. How is the star keeping itself stable? Nuclear fission. Inside the core of the star, hydrogen molecules are being forced to fuse together to create tremendous energy, light, and heat. Also producing a waste material of helium. So then what happens is that energy pushes back on gravity. So the star stays stable. If gravity's force and nuclear fission force is equal, the star stays stable. But over millions or billions or trillions of years, what happens is star starts to grow big, really big. So that's called red giant phase. So then it's huge, it's really red. And then it starts to shrink back down, shrink, shrink, shrink. But that red star, or red giant, was much heavier than that small star. Where did all the gas go? It shed it off. It's thrown off into space. All that. So it creates beautiful nebulas. And then all that remaining is the core, which might turn into red dwarf or white dwarf, and then finally black dwarf, and then last, nothing. So then all that gas that was in the star is out into space. And that creates a nebula, and the process starts again. But then for really massive stars, like about 50 times the size of our sun, there's a different story. Once it grows really small, but it still has all that gas, same amount of gas, and then it explodes in a supernova. So then it explodes, really hugely explodes, and then all that gas and other material is flinged up into space. And then what happens is the remaining core might turn into a neutron star or a black hole. So then if the star is really huge, its core turns into a black hole. And then if it's not so huge but still is huge, its core turns into a neutron star. So then that is the lives of stars. Thanks for watching. Bye.